One morning you open your phone and the navigation app is pointing in completely the wrong direction. You're clearly walking north, but the app says south. You pull out a compass. Same result. The needle is pointing toward the South Pole. You look up, planes are flying in completely the wrong direction. Every flight has to recalculate its route. At the harbor, ships give up on departure. The compass is useless. And when night falls, auroras spread across the skies above central Seoul. Green, red, and violet curtains of light fill the city sky. It's breathtaking. But anyone who knows what this means feels a chill run down their spine. This isn't a movie. This is something that has actually happened hundreds of times in Earth's history. It's called a geomagnetic reversal, Earth's magnetic field flipping upside down, the north and south magnetic poles switching places, and scientists say the early signs of exactly that are already showing up right now. Earth's magnetic field is weakening. The magnetic North Pole is moving several times faster than usual. A region where the field is unusually weak has appeared on Earth, and it's growing. No one knows when the next reversal will come. It could be hundreds of years from now or tens of thousands. But what would happen to modern civilization when it does, that we can start thinking about right now? That's what today's video is about. Earth has an invisible shield, a magnetic field that wraps around the entire planet. In terms of size, it covers a space dozens of times larger than Earth itself. Its shape is like a flattened donut bubble, with Earth nestled inside. The side facing the sun is compressed, because particles streaming from the sun are constantly pressing against it. Without this shield, Earth would be an entirely different planet. The sun continuously blasts out an enormous stream of particles. We call this the solar wind. If that solar wind hit Earth directly, the atmosphere would slowly be stripped away. Over billions of years, it would disappear entirely. The water would evaporate. Earth would end up looking like Mars. Mars is exactly that example. Mars once had a magnetic field, water, atmosphere, and flowing rivers. But as its magnetic field weakened and disappeared, the solar wind gradually stripped its atmosphere away. Today, Mars has an atmosphere barely 1% as thick as Earth's. Almost no water remains. It's Earth's magnetic field that has kept us from the same fate. The magnetic field deflects incoming solar particles, sending them flowing around the planet, the same way a boulder in a river splits the current around both sides. Some of those deflected particles get channeled toward the polar regions, where they collide with the atmosphere and release light. That's what an aurora is. So where does Earth's magnetic field actually come from? Cut Earth open in cross-section, and you find several distinct layers. From the surface inward, the crust, the mantle, the outer core, and the inner core. The outer core is the source of the magnetic field. It's a layer of liquid metal, mostly iron and nickel, molten like liquid steel, and it's constantly in motion. Heat from deep inside Earth drives convection currents. Hot liquid metal rises, cooler metal sinks back down. Earth's rotation adds another influence to this motion. Moving metal generates electrical current. Electrical current generates a magnetic field. Earth's interior is essentially one enormous natural generator. The key is that this motion never stays the same. The flow patterns of the liquid metal shift gradually. Those shifts affect the shape, direction, and strength of the magnetic field. Usually these are small fluctuations, but sometimes something much larger happens. Can Earth's magnetic field actually flip? It already has, hundreds of times. And the evidence is locked inside rock. When lava cools into rock, the tiny magnetic mineral particles inside it lock into the direction the magnetic field was pointing at that exact moment, frozen like compass needles. Tens of millions of years later, those particles still point the same way. Scientists analyzed the magnetic direction of rocks worldwide, sorted by age. The results were startling. Over Earth's 4.5 billion year history, the magnetic field has reversed hundreds to thousands of times. And there's no regular schedule. It happens on a completely unpredictable timeline. The most recent full reversal happened about 780,000 years ago. It's called the Matuyama-Brunhes reversal. Before that, about 42,000 years ago, there was a brief event. The field flipped temporarily and returned to normal. This is known as the Lachamp event. The current orientation of Earth's magnetic field has held for about 780,000 years. The average interval between full reversals is 200,000 to 300,000 years. We're already far past that average. In movies, magnetic reversals happen explosively, like some catastrophic natural disaster that flips the world in an instant. In reality, it's far slower than that. Even the fastest known reversal took hundreds of years. Typically, the process plays out over thousands to tens of thousands of years. During a reversal, it's not just a simple north-south swap. The magnetic field fragments into pieces. Instead of one magnetic north pole, several appear at once across the globe. There could be 3 poles or 5. And during this time, the overall strength of the field drops sharply, potentially falling below 10 to 20% of its current level. A magnetic field 1/10 its current strength. Multiple weak poles scattered around the globe. This state could last for thousands of years. You can look out the window right now and feel nothing different. But when you look at the measurement data, the picture changes completely. Precise measurement of Earth's magnetic field began in the 1830s. We now have nearly 200 years of data. And that data consistently shows one thing: Earth's magnetic field is getting weaker. Since the 1850s, the field's overall strength has declined by about 9%. For a geological process that normally moves on timescales of thousands of years, that's a remarkably fast drop. On top of that, the magnetic North Pole is moving fast. It used to sit over northern Canada. For most of recorded history, it drifted at a steady 10 kilometers per year. Then in the late 1990s, it suddenly accelerated. Since the 2000s, it has at times moved over 50 kilometers per year, several times its previous speed. Even today, it races towards Siberia far faster than before. This change is real enough that aviation authorities worldwide have had to regularly update their aeronautical charts. Multiple airports have already renumbered their runways because of it. And then there's the South Atlantic anomaly. In the South Atlantic, between South America and Africa, the magnetic field is unusually weak. Satellites passing over this region experience electronic malfunctions far more frequently. Astronauts report seeing strange flashes of light when passing over this region, cosmic ray particles striking their retinas. The weaker field lets more radiation through. What makes it even more notable is that this anomaly is growing. Recent research suggests it may be beginning to split into 2 separate patches. Are all these signs pointing toward a reversal? Honestly, no one can say for certain. The field naturally fluctuates. But the weakening strength, the accelerating pole movement, the growing anomaly, for a coincidence, they're all pointing in the same direction. In 2021, a fascinating study was published using New Zealand's kauri trees as evidence. Kauri trees live for thousands of years, and every annual ring records the atmospheric conditions of that year. Researchers excavated massive kauri logs that had died and been buried underground thousands of years ago. Their rings contained a detailed record of the Lachamp event approximately 42,000 years ago. The Lachamp event was not a full reversal. The field flipped temporarily and returned about 1,000 years later. But during that 1,000 years, the field's strength dropped to just 6% of what it is today. Analysis of the tree rings showed that atmospheric carbon-14 spiked dramatically during that period. Carbon-14 is produced when cosmic rays collide with the atmosphere, meaning far more cosmic radiation was reaching Earth. When you piece together the other evidence from this period, an intriguing picture emerges. Around the same time, large animals across Australia and Eurasia were vanishing one after another. Australia's giant kangaroos, giant wombats, and megalania lizards were already in decline, and across Europe and Asia, woolly mammoths, woolly rhinoceroses, and cave lions were dwindling too. A 2021 study proposed that the Lachamp event may have played a part in this. As the magnetic field collapsed, far more UV radiation and cosmic rays could have reached Earth's surface, with possible effects on the ozone layer. The hypothesis is that for large animals already struggling under pressure from human hunters, this environmental shift may have added one more burden. This is also around when Neanderthals disappeared, vanishing from the fossil record some 40,000 years ago. The timing oddly overlaps with the start of the Lachamp event. Homo sapiens, however, survived. And intriguingly, this is precisely when cave art in Europe explodes in volume, the era of Lascaux and Altamira's famous paintings. One intriguing hypothesis: people may have simply spent more time sheltering in caves from intensified cosmic radiation. Of course, none of this can be pinned on the Lachamp event alone. Climate change, human hunting, and other factors likely played major roles too. But the sheer number of changes clustered around the same period, with the Lachamp event sitting right in the middle of it, remains a fascinating subject of debate. Now for the real what if. What would actually happen if a reversal started unfolding right now? Remember, reversals take thousands of years. The world doesn't flip overnight. GPS and satellites. Think for a moment about how much of modern society runs on GPS. It's not just your phone's map. Aviation navigation, maritime routing, freight logistics, precision farming, the timestamps on every financial transaction, all of it depends on GPS. As the magnetic field weakens, satellites get exposed to more cosmic radiation. Their electronics malfunction and their operational lifespans shorten. Low-orbit satellites take the hit first. GPS satellites, communication satellites, observation satellites, they begin dropping signal intermittently. What currently happens only over the South Atlantic anomaly would expand to cover the entire globe. The power grid. Sometimes the sun unleashes a massive explosion, a coronal mass ejection. It sends an enormously powerful surge of energy toward Earth, far stronger than ordinary solar wind. A strong magnetic field shields us well. But there's a real-world example. In March 1989, in the Canadian province of Quebec, a powerful solar storm shook Earth's magnetic field and generated currents along the ground. All of Quebec lost power in just 90 seconds. 6 million people went 9 hours without electricity. What if the same solar storm hit while the field was less than half its current strength? Instead of one Canadian province, the impact could spread across entire continents. A single large transformer takes months to manufacture. There's no global production capacity to meet simultaneous continent-wide demand. A blackout lasting months across entire continents is theoretically possible. Birds and animals. Scientists long wondered how birds migrate thousands of kilometers with such precision. Research has now revealed molecular structures in birds' eyes that can sense magnetic fields. Birds are essentially seeing the magnetic field visually. When that field shifts or becomes chaotic, their migration routes fall into chaos too. Billions of migratory birds fly the wrong direction. Sea turtles are no different. They use the magnetic field to navigate back to the exact beach where they were born, sometimes after decades at sea. If that ability is disrupted, nesting becomes nearly impossible. Dolphins and whales navigate by magnetic field too. Some research links mass strandings to magnetic anomaly zones. Bees, salmon, sharks all use the field. When it breaks down, their behavior changes, the food chain shakes. Auroras would appear worldwide. As the field weakens, solar particles penetrate to far lower latitudes. During the most extreme phase of a reversal, auroras could be visible even near the equator. Seoul, Tokyo, New York, Singapore on the equator, all could see auroras. In one sense, it would be spectacular. But knowing what it signals, a field at its weakest, makes it hard to simply enjoy. Radiation. A weakened field means more high-energy particles reaching the surface. A single dose of exposure won't cause anything noticeable right away. But as the cumulative exposure builds up over decades, it could have unexpected long-term effects on human health and on the biological rhythms of living things. People near the poles and flight crew at high altitudes would feel it first. The ozone layer would also be affected. Partial damage means more UV radiation reaching the surface. Hearing all of this, you might feel genuinely afraid. But here's an important fact. Earth's magnetic field has reversed hundreds of times throughout history, and life on Earth has survived every single time. Even during a reversal, the magnetic field doesn't vanish entirely. It weakens and fragments, but some protective effect remains. and Earth's atmosphere acts as a secondary shield regardless. The issue is modern civilization. Humans tens of thousands of years ago had no GPS, no satellites, no power grid. If the magnetic field flipped, you just learned that north was the other way and adapted. We are not in that position anymore. When power goes out, hospitals stop functioning. When refrigeration fails, food spoils. When GPS goes down, logistics collapse. When communications fail, financial systems shake. A magnetic reversal itself is unlikely to cause human extinction. But whether modern technological infrastructure can withstand that kind of change, that is a very different question. Scientists are taking this seriously. The European Space Agency has 3 swarm satellites in orbit, monitoring Earth's magnetic field around the clock. Their data shows the rate of change is the fastest ever recorded in human history. NASA and space agencies worldwide operate solar storm warning systems. When a major solar eruption occurs, it takes 1 to 3 days to reach Earth. That window is enough to switch satellites to safe mode and for power companies to prepare. Power companies are adding geomagnetically induced current protection devices to transformers. It hasn't reached all global infrastructure yet. But the direction is toward awareness and preparation. Ultimately, even if a reversal begins, it will unfold over thousands of years. There is time to measure, to track, to build response systems. Whether humanity uses that time well is what matters. Earth's magnetic field is invisible to our eyes. We can't touch it, can't smell it. And yet, for billions of years, it has been an invisible shield protecting life on this planet. But even at this very moment, Earth's magnetic field is changing. The South Atlantic anomaly is expanding, and the magnetic North Pole is racing towards Siberia. Scientists are watching this data every single day. How fast this change will proceed, whether it will lead to a true reversal or just wobble and return, nobody knows yet. The Earth knows the answer, but it hasn't told us yet. Perhaps the most important thing is the very fact that we are measuring and trying to understand these changes. Thousands of years ago, humans didn't even know magnetic fields existed. Today we are measuring them from space with satellites. Even if the day comes when compass needles point south, it will not be the end. Earth has gone through this dozens of times and is still here. Life survived every time. It will again, if we are ready. If you found today's video useful and interesting, please subscribe and hit the like button. Next time, I'll bring you another hidden secret of our Earth. Until then, leave your questions in the comments.